Hi, welcome back to my channel. Well, in this video we'll try to learn some of the basic concepts of statistics. Actually, I'm starting a series of lectures regarding statistical methods, which will be quite useful for the students who are doing their bachelor's or post-graduation in forestry or agricultural sciences. So let us start with the basic definition of the statistical sciences. Statistics is a science of collection, analysis, presentation, and reasonable interpretation of the data. So in statistics, what we used to do, we used to collect the information, then we used to analyze it with the help of standard statistical procedures, then we used to present it in the form of tables, in the form of graphs, and after that we used to give our conclusion or the interpretation based on all these three aspects. So the key aspects is collection of information, analysis of information, presentation of information, and the conclusion or the interpretation of the information. And information is nothing, it is the data. It is a collection of observations which can be in numbers, which can be in image, which can be in text form also. There are so many definitions which are given to this statistical science. Some say it is a science of average, some say it is a science of probability, but in my opinion it will always remain as a science of variations, because variability is very important. As far as the basic data driven decisions are concerned, three important aspects are there. One is comparison, another one is relationship, and the third one is prediction. So in all these three categories you will find there will be an existence of variability. So statistics will always remain as a science of variability, but in nutshell we always used to say that it is a science of collection, analysis, presentation, and reasonable interpretation of the data. But in the world which we are living in, this data, which is a collection of information, which is in terms of numbers, which is in terms of text, which is in terms of image, it has increased in every aspect. It has increased in volume, it has increased in velocity, it has increased in variety. So is the case with the way we look at the statistical sciences. So statistics is nothing, every word of this statistics has got its meaning. It is strengthening technological advancement through implementing systematic techniques in contemporary sciences, because it provides a rigorous scientific method for gaining insight into the data. So this is what statistics is. Now everything is revolved around the data. What this data is actually, the data refers to the raw facts, figures, or the information, like I have said, that are collected, stored, and processed. The data can be in various forms such as numbers, text, image, or any other representation of the facts. It is the foundation upon which information and knowledge are built. So everything is revolved, or we can say the statistical sciences, it is a science of data, it is a science of information, it is a science of numbers, it is a science of text, it is a science of image, or rather we can say it's the grammar of all sciences. You know, every science requires statistical sciences to prove their experimental findings. So this is the importance of statistics. So in every sphere this statistical sciences is used. So moving ahead, now since we are talking about data, we have two important categories of data. One is quantitative and another one is qualitative. As far as this quantitative data is concerned, the data that can be measured with numbers such as duration or speed. And further, there are two important categories of this quantitative data. One is discrete and another one is continuous. The discrete is nothing, they are the whole numbers that can't be broken down, such as a number of items, while the continuous are the numbers that can be broken down, such as height or weight. And further, this continuous quantitative data is further categorized into intervals and ratio. Intervals are the numbers with known differences between the variables, such as time, and ratio are the numbers that have measurable intervals where differences can be determined, such as height or weight. Now the another important type of data is qualitative, which is always a non-numerical data. That is categorical, like we have a binomial category like yes, no, male, female, eye color. And further, there are two important categories. One is nominal and another one is ordinal. The nominal data is used for naming variables like hair color. There is no preference. It can be male, female, it can be yes, no. Then ordinal data is always in the form of an order. The data used to order or used to describe the order, such as happy, unhappy, neutral, or we are giving the different grades to herbicides or pesticides. So that pertains to ordinal data. So the two important categories are quantitative and qualitative data. Now, as far as the classification of the data is concerned, there are four important classifications. That is, the first one is geographical. The geographical classification or spatial classification, that means sometimes the data can be classified area wise, such as in states, towns. So we call that classification as geographical classification. Or sometimes the data can be classified on the basis of time and arranged chronologically or historically, then we call it as a chronological. Or sometimes it can be classified on the basis of attributes, on the basis of characteristics which can't be measured, so that is qualitative. Then the quantitative is a data that can be classified in the terms of magnitude and which can be measured. Now this data is very important. Now how we are going to present it? There are two important aspects. One is numerical presentation or graphical presentation, or we can say the numerical summary or graphical summary, because once you have collected the data, once it is collected, it is in the raw form. So how you are going to grasp the basic information, the basic structure, the basic summary of the data, that can be done by means of two ways. Either you can get the summary of your data or the idea about what my data set is, what these collection of observations say. For that we have two important categories. We can do the presentation or summarization of data numerically or graphically. So as far as the graphical summary of the data is concerned, since everything around us is visual, our eyes can easily differentiate from red to green, yellow to blue, because everything around is visual, be it our mobile phone, be it this gadget on which I am recording, be it television. So we always look for the overall pattern and for striking the deviations from the pattern. An overall pattern usually described by shape, center and spread of the data, because the overall pattern, it can be described by shape, center of gravity or the dispersion of the data, which can be graphically visualized. Because once if you have a data which is in numerical or a tabular form and the same is depicted in terms of a graph or an interactive plot, our eyes or our mind quickly grasps the amount of information which is present visually in comparison to which is in numbers. So we can do the summarization of data by means of graphs. The first one is bar graph. Bar graph is a graphical representation of a categorical data by means of different graphs. Now there is another important category that is known as a pie chart. Pie chart is usually used to show the percentage of a whole area and represents the percentage to a set point in a time. So usually when you are dealing with a data set where you want to put your data in terms of percentage or something like that. Now there is another type of data visualization or graphical summary, that is histogram. Histogram is a type of a bar graph, like the representation of data that buckets a range of classes into columns along this horizontal axis. Then the last category is this box plot. Box plot is usually used, or we can say it is the advanced version of all these three, because in box plot we can get an idea about the variability, we can get the idea about the amount of variation or the minimum, maximum or the extremes in our data set, or where we can figure out where are our positional average, which I will discuss in the upcoming slides also. So this is the basic overview how we can do the graphical representation by bar graphs, by pie charts, by histograms or by box plot. Now there is an important concept also in statistics before going to the numerical summary, that is frequency distribution, which is nothing. It is a representation either in a graphical or a tabular format that displays the number of observations within a given interval. For example, we have a category of students where we have measured their weights in kilograms, like we say 31 to 35 kg. This is an interval where 9 students belong to this category, 5 students belong to this category. So this is the way how we can do the categorization. Since the frequency distribution is concerned, it refers to the data classified on the basis of some variable that can be measured, such as prices, like weights in this example, height or weights. Now, three important concepts: class limit, class interval, and class frequency. So this is the class limit 31 and 35. Class limits are the lowest and the highest values that can be included. So this is a class, and 31 and 35, these are nothing, these are the highest and lowest values. So these are the limits of this class. And what is class interval? It is the difference between the upper and lower limit of a class and is known as a class interval of that class. So difference between 31 and 35, 36 and 40. Now what is the frequency? Like in this case, 9 is the frequency of this first category. So the number of observations corresponding to a particular class is known as frequency of that class. So in nutshell, we can say this is nothing, this is a tabular representation or a tabular format that displays the number of students in this case within the given interval of weight. So this is frequency distribution. Now moving ahead, as far as the numerical summary of the data is concerned, we have two important categories or aspects of this numerical summary. One is center of gravity, another one is spread. So we are interested to see the center of our data of information as well as the spread or the variability that is present in our data. So how we are going to figure out the center, how we are going to figure out the spread? For that we have two important categories, or two important tools, or two important foundation we can say, which forms the foundation of statistics. The first one is measures of central tendency, and the second one is the measures of dispersion. So let us start with the measures of central tendency. As far as this measures of central tendency is concerned, these are the values of a variate which are representative of a series or a distribution as a whole. So this is nothing, it just gives an idea about the basic representation or the central idea, which is our center or the focal point. There are three important measures of central tendency. The first one is mean. Generally speaking, we always used to call this as an arithmetic mean, but actually there are three different categories for this, or we in the common layman's language we call them average. So we have some first category is mean, second one is mode, and the third one is median. As far as this mean is concerned, there are three important categories. One is arithmetic mean, geometric mean, and harmonic mean. And we have another category that is mode, and we have third one that is median. These are actually called the average. These first three types are called mathematical average, and this one is called as a positional average. So we have different categories. One more mean is also there, that is known as weighted mean. So one by one we will discuss them in this video. So as far as this mean is concerned, mean represents the average value of the data set. It can be calculated as the sum of all values in the data set divided by the number of the values, or in general we can say it is considered as an arithmetic mean. Now we have some other types of the measures of this central tendency, which are usually known as mathematical average. The first one is geometric mean, harmonic mean, and weighted mean. In geometric mean is nothing, it is the nth root product of the n numbers, while as harmonic mean is nothing, it is the reciprocal of the average of reciprocals, or sometimes we say it is a reciprocal of the arithmetic mean. And weighted mean, where some values contribute more than others, because in traditional arithmetic mean we assume all the observations in a data set where we want to calculate the arithmetic mean, they are same. But there are some circumstances where different observations have more different type of weights, then at that time we used to apply weighted mean. So let us proceed. As far as arithmetic mean is concerned, it is nothing but the center of gravity of a frequency distribution. The formula of arithmetic mean is x bar, this capital X bar, or it can be sometimes used as small x bar, although this is a separate topic, what small x is, what capital X is, because we have not completed the concept of sampling techniques. But the sake of information for all the student, this capital X bar is known as population mean. But in this case, how we are going to calculate this sample mean or population mean? It is nothing. We used to get the sum of all observations divided by the number of observations. That is why we have an algebraic sign here, that is summation, which is nothing. This is summation I range from 1 to n, xi divided by n. Since when we write capital X, you have to write the capital N also here and capital N also here. Here we have by mistaken typed small n, but whenever you are writing a capital N, that means you are dealing with a population or a capital X. This assumes that all observation in any class are concentrated at the middle of the class. Now there are some merits and demerits of this arithmetic mean. The merits are concerned, it is rigidly defined, it is easy to calculate. If the numbers of the items sufficiently large, it is more accurate. So more is the size of the data, so more accurate information it will give. It is calculated value and it is not based on its position of the series, so it's not affected by sampling fluctuations, so it's a good basis for the comparison. But at the same time, there are some demerits also. That means it can't be obtained by inspections, and one of the important demerit of this arithmetic mean is it is affected very much by the extreme value. That is why it can't be calculated for the open-end classes. Because if we say that how can we say a particular average is an ideal, there are some features for that it should be easily defined, it should be based on all observation, it should not be affected by sampling fluctuation, it should be capable of further mathematical or algebraic treatment. And another important thing is that it should not be affected by the extreme observations. But this arithmetic mean is affected by the extreme observations, but rest of the features it used to follow. So that is why it is used to we used to call the arithmetic mean as the most stable measure of central tendency. Then how we can compute, there are two categories in that. Ungrouped data, where we don't have frequencies or categories, or data is not in terms of class intervals. If it is in class intervals or we have some frequencies, then we have to use this formula for that. For that method is a simple summation xi divided by n, and there's a deviation method also, why we used to take an assumed mean. Here n is the number of observation, xi are the given values, a is an assumed mean or arbitrary value, d is nothing, is a deviation of a particular value from that assumed mean. Then same is the case with this, but the only thing is here this fi is included, the frequencies are included. So by the way of example, I will make you understand what it is. For example, if the weight of 7 chicks are 89, 94, 102, 107, 108, 115 and 126 or 126 gram, find the arithmetic mean by means of direct as well as deviation. This is an ungrouped data, we don't have frequencies. So what we have to do, the first thing is that we have to get the sum of all observations if we want to apply this DAG formula. Then divide this sum by the number of observation. In this case, how many? We have 7 number of observations. So 741 divided by 7 is equal to 10586. So 105.86 grams is the average weight of these chicks, of these 7 chicks. So if we want to apply or we want to calculate the arithmetic mean by means of this deviation method, what we have to do, we have to get the assumed value. Assumed value is usually taken in the middle of the series. So in this case, we have taken assumed mean value as 102. Then what we have to do, we have to deduct every observation from this assumed value, that is 89 minus 102, 94 minus 102. And after that, what we have to do, we have to get the sum of all these, like in this summation di, then 27 upon 7, the value which we will get, then we will add that with 102. It will be around about 3 point something. So in both cases, we used to get the same arithmetic mean. Then if we have a data set which is in terms of class intervals, or we can say a group data, we have a data set. The following are 405 tomato plant heights collected from a particular plot, find the arithmetic mean of the plant by means of direct and indirect method, by means of direct and or deviation methods also. So here we can see we have a plant height which is in the form of categories. So the plants which are in the category of 8 to 12 centimeters, they are 6 in numbers, and same is the case with others. The first thing is we have a data set which is in class interval. So how we are going to get it? So simply we'll get the average. 8 plus 12 is 20, 20 upon 2 is 10. So similarly for rest of the observations we can get this xi. The next step is that we have to multiply this xi with its associated respective frequency. Then 10 multiplied by 6 is 60, and same is the case with other. Here the capital N is the sum of frequencies, and here what we have to do, we have to get the summation fi xi. Then we have to apply this deviation. Deviation is nothing, that is xi minus a. If we are going to apply this deviation method, here the assumed value which we have taken, that is 30, here you can see. Then in the similar way what we have to do, since we have calculated the deviation, then what we have to do, we have to again multiply this deviation with its respective frequencies. Then the same way, a simple arithmetic operation, we have to add all these values. Since we have calculated all these, then in both these cases we will expect the same amount of this average. Then actually it is not summation fi xi, it is summation fi di here, because we have already calculated the summation fi xi here. So this is the way how we can calculate this arithmetic mean by means of if we have data set in if we have a group data. Then geometric mean, like I have said, it is the nth root of the product of n numbers. The geometric mean of n numbers is defined as the nth root of their product, and it is nothing, it is the square root of all the observations. Note, like the symbol summation denoting sum, this symbol is used for the product moments for the product. The important thing about this is that the geometric mean cannot be calculated if any of the value in the series is 0 or negative. So we have to be very cautious. And the important thing is that it is used to calculate the rate of growth and rate of interest. So quite a bit used in index numbers. So the remark is the geometric mean can't be calculated if any of the value in the series is 0 or negative. And obviously if something is 0 in square root, then we can't calculate it. Then harmonic mean, like I have said, that it is the reciprocal of the arithmetic mean, or we can say it is the reciprocal of arithmetic mean of the reciprocals of the observations, which is here. Harmonic mean is denoted by h, and upon summation xi divided by, that is why it is the reciprocal of reciprocals of the observation. This average gives greater importance to small items and is useful only when small items have to be given a very high weightage. Same as the case of weighted mean also. It is the only average to give the average rate when time factor is variable and act being performed is constant. So this is quite significant thing about this. Now there is an important relationship between arithmetic mean, geometric mean and harmonic mean. The first one is it is always greater than these two, and geometric mean is the square root of arithmetic mean. For example, we have a question here: compute the arithmetic mean or geometric mean and harmonic mean of these observations 5, 8, 12 and 15, and show that this arithmetic mean is greater than geometric mean and harmonic. Simply, in order to get the arithmetic mean, what we will do, we will sum all these observations 5 plus 8 plus 12 upon 1, 2, 3 and 4. So we will get the arithmetic mean, that is 10. For geometric mean, what we have to do, since it is the nth root product, what we will do, we will simply get the product of all these 5 into 8 into 12 and 15. Then we will get the positive square root of, that is 9.2. Then the harmonic mean, it is the reciprocal of the observations. So here it is n, that is number of observations are 4, then 1 upon 5, then we will get the LCM of this, then it is 8.4. Since 10 is greater than 9.2, then 8.2, so the above result satisfied that following relationship exists. And then weighted mean or weighted average, we can say, is a measure of central tendency that takes into account the importance or weight of each value in a set. It is calculated by multiplying each value by its corresponding weight, summing up these products and then dividing by the sum of weight. If we assign different weights, say W1, W2 up to Wn to the observations which range from x1 to xn respectively, then the weighted mean is nothing. It is summation wi(xi) divided by summation yi. Weighted mean is commonly used in various fields and situations where data points have varying degree of importance or significance. This is very important. Then we have another type of arithmetic, or we can say the average, that is median, which is known as the positional average. Median is the middlemost value of the data set which we use to get, or we can say a value of variate which divides a series or a distribution into equal parts. That is median. For ungrouped data, when the number of observations are odd, it is calculated like this: n plus 1 upon 2 value. And if it is even, then we have to get the average of like this: n upon 2 and n upon 2 plus 1. And for group data, we have to calculate this median by means of this formula, where L is the lower limit of the median class, F is the frequency of the median class, and M is the cumulative frequency of the class preceding the median class. C is the class interval of the median class, and here this is the total number of observation. For example, the number of runs scored by 11 players of a cricket team school are 5, 19, 42, 11. So it is 1, 2, 3, 4, 5, 6. So 11 is nothing, it's an odd number. So simply we will get this by means of this formula: n plus 1 upon 2, where n is 11. That means first we have to arrange the data in ascending order. Then sixth value is, now this sixth value in the data is 27. So the median here is 27. So this is the way how we can calculate it if we have data in this odd numbers. In case of even numbers, what we have to do, first we have to arrange the data in the ascending order. Then we have to use this formula, that the average of n upon 2 and n upon 2 plus 1 term. Then simply we can get, this is very simple. But as far as this group data is concerned, for example, find out the median of the following frequency distribution of 180 sorghum ear heads, where we have weight heads, which is in the form of categories, and we have number of ear heads. So how we can calculate this median? For that, what we have to do, we have to find out the median class first and median frequency, and after that we have to apply this formula here, that is L plus n plus 1 upon 2. Then we have to apply this n plus 1 upon 2, that is 180. This is the total frequency, divided by 2, that is equal to 181 divided by 2, which is equal to 90.5. Then we will substitute all these values in this formula. Then we can get a median class for this group data. Now moving ahead, mode, it is the most frequently occurring observation in the data set, and mode is usually represented the most frequently occurring value in the data set. And again, in case of ungrouped, it is very easy to figure it out. Observation which occurs majority of the times. If we have a data set, suppose in this case 33 occurs 1, 2, 3, 4, 5 times, so it is the mode. But as far as the group data is concerned, we have to apply this formula. For example, there is a marks obtained by the 89 students in a particular subject. This is a mark categorization, and 4 number of students have got a marks within the range of 10 to 15, and 5 students have got within the range of this. So for that we have to apply this formula. The L is the lower limit, F is the frequency of the model class, and after that what we have to do, we'll simply have to apply this formula. We have to get the first frequency for the succeeding class and the preceding class. This is very simple. And after that, what we will do first is to get the frequency of the model class, then frequency this F1 of the preceding, and after that the succeeding class. Then we have to substitute all these values in this formula. Then we will get very easily, since this mode is quietly used to get the model class, and in case of business industries, especially in shoe size, it is quite usually used. Then positional average. Positional average are those values of a variate, or those average which divides a series or a distribution into equal parts. We have 3 important categories in that: quartile, deciles, and percentiles. Quartiles are 3 in number and they divide a series into 4 equal parts. Deciles are 9 in number and they divide the series into 10 equal parts. And percentiles are 99 in number and they divide the series into 100 equal parts. Second quartile, fifth decile, and 50th percentile are almost equal because of the fact all these three divides the series into two equal parts. Then since in case of measures of center tendency, we know we can get the idea about the center of gravity of a distribution, or we can say the measures of the center tendency are the values of a variate which are thoroughly representative of a series or a distribution as a whole. And if we will take an example of arithmetic mean, it gives us an idea about the center of a gravity of that particular series or a distribution. But how much of the values of that variate deviate from that particular average, that idea is to be executed by means of these measures of dispersion. It is an index of spread, it is an index of variability. The first important measure of dispersion is range. It is based on only two extreme points. One is the largest one, and it is the difference between largest and the smallest one. Since this is based on only two observations, and there are some important features for an ideal average, or we can say an ideal measure of central tendency, or an ideal average, or an ideal measure of dispersion. In both these categories, they follow the same features, that they should be based on all observation, they should be rigidly defined, they should be easy to calculate it, and they should be able to capable of mathematical or algebraic treatments. And the final one, they should not be affected by the extreme observation. Like in measures of center tendency, arithmetic mean is the most stable measure of center tendency, but here we have to find out which is the most stable measure of dispersion. Since range is only based on two observations, so this is a crude measure of dispersion. But as far as this mean deviation is concerned, it takes a assumed value, but within this absolute category, it takes the absolute deviations into account, so it ignores the signs, so it is not capable of further mathematical or algebraic treatment. But as far as this standard deviation is concerned, if we will take into account the second property of mean, that is algebraic sum of squares taken from the deviation, or algebraic sum of squares of deviation taken from the mean is not equal to 0. So if we will extend that formula, then we will get the positive square root of 1 upon n. Then this is nothing, this is the deviation, and variance is nothing. This is positive square root is taken out, then it will become the square. But usually standard deviation is used because it retains the same units on which the measurements of a particular variable are done. Then there is another important measure of dispersion, that is interquartile range. This is the difference between third quartile and first quartile. It takes into account only 50%. So this is not a measure of this is not a stable measure of dispersion, neither mean deviation nor interquartile rate. Only standard deviation is considered to be the ideal measure of dispersion. Then how can we calculate a standard deviation of some observations? Like first, what we have to do, for example, calculate the standard deviation of a tomato plant, which is in kgs plot for a particular variety from 7 plots. The first thing is that how we can get it from the previous formula. First get the sum, then get the sum of squares, that is summation xi square is nothing, that is square of each and every observation. At the same time we have to add them, then put these values or substitute these values in there. So the overall dispersion, the standard deviation of this 7 tomato plants is 1.55 kgs. Then coefficient of variation. This is quite widely used when we have to compare different series in terms of consistency, and we have to find it out which one of the series is consistent and which of the series is not consistent. So since the previous measures of dispersion they are absolute measures of dispersion because they are expressed in the units in which the observations are recorded. But a measure of dispersion which is independent of unit of measurement and is therefore useful for comparison between different population and for different characters is provided by coefficient of variation. It is nothing, it is the ratio of the standard deviation and the mean multiplied by 100, or it gives an idea about the percentage of variation that is present in a particular mean. So less the coefficient of variation in a series is better or more consistent that series is. So if we talk about the basic concepts of statistics, two important bases of statistics, or we can say when we talk about statistics we always thought about collection of a data, then we used to analyze the data, then we used to present them and finally give our interpretation. But interpretation of all statistical theories, or we can say the interpretation of the data, is based on the joint consideration of central tendency and dispersion. So mean and standard deviation, they form the foundation of any statistical interpretation. So whenever you are going to give your interpretation in any kind of research, then two things are very important. Give your interpretation where both thematic mean, or we can say the central tendency, and the dispersion are taken into account. Because when you are seeking the comparison, because majority of the time the comparisons are done on the basis of average, but when you give your final execution or final interpretation, you have to take into the variability into account. So these are the two important concepts of statistics, that is central tendency and dispersion. In next video we will try to get an idea, or we will try to learn about the basic concepts of probability. Hope you will like this video, and if you have any questions or comments, please comment on the comment section below. Thank you very much.